Today we're going to talk about transformations. Transformations are things that change a figure in the coordinate plane but do not change the shape. We'll change the position, we might even change the size, but we're not going to change the shape. The first type of transformation that we're going to look at is called a reflection. A reflection is a transformation that flips a figure over one of the axes. So flip goes in this blank. And one way you can remember that is reflection and flip both have the FL sound. So reflection and flip. So here we have the pre-image, A, B, C, and then we have the image, A prime, B prime, C prime, is how you read that. And the image is going to be the new one. The one with the primes is the new one. And in this case, we reflected triangle ABC over line M. Let's look at example 1. Determine whether each image is a reflection. Right, yes or no. We need to see, this is where we started, this figure here, and we flipped it over this way, and nothing else changed, but we did flip it, so we're going to say yes, that is a reflection. B, reflection, have to flip this over, and if we flip that over it wouldn't match. This one actually would just get slid, and we'll talk about that type in a second. So that's no, that's not a reflection. Okay. Let's look at example 2. It says how many lines of symmetry? Remember, lines of symmetry, and it's also called a fold line, where we can fold the figure over onto itself. That's also a line of reflection. Let's look at this one. How many different ways can we fold this over onto itself? Well, if we draw a line straight down the middle, we can fold it left to right, and if we draw a line through the middle, we can fold it top down. So that's going to be 2 lines of symmetry. Let's look at B. Well, we can fold this. Again, we can fold it right down the middle, and we can fold it middle this way, and we can fold it through here and fold it over onto itself, so that's another one. If we do that, we can also do this one. So in this case, the line of symmetry is 4. For C, you can see that we can fold this right down the middle onto itself, and we can't fold it up or any other way, so that one's going to be 1. So we've got 2, 4, and 1 for our answer so far. Let's look at D. And the only place I see where we can fold this is right down the middle. Fold it over onto itself, so that has 1 line of symmetry. Now let's look at this one. I'm going to let you look at this for a second before I give you the answer. How many lines of symmetry does this figure have? Okay. Let's see, if we take a line, put it right down the middle here, we can fold that over onto itself. If we put a line through this vertex, straight across, that's 2. A line through this vertex, 3. This one, 4, and through this one, 5. So in that pentagon we have 5 lines of symmetry. Example 3. Graph the point and its image under the given reflection. A is at -3, positive 4. -3, positive 4. Right there, there's A. We're reflecting it over the x-axis. The x-axis is this axis here. Be very careful about that. So we're reflecting it, so we're going to put it the same distance below it as it is above it. So this one we're 4 above it, so we're just 1, 2, 3, 4 below it. And as we learned earlier, that is going to be A prime. and that's how we reflect points. Alright, this time we're going to reflect over the y-axis, and we've got, starting with A, 4, 1, 1. This time the y-axis is this one here, so we're going over 4 to the right, so we're going to go over 4 to the left. This is A, and this is A prime. Example 5. Triangle ABC with coordinates -2, 4, 3, 5, and -2 is reflected over the x-axis. What are the coordinates of C prime? Alright, well, let's look at this. Let's go ahead and plot these points. ABC is -2, +4, 2, 3, 4. That's A. B is at +3, +5, B, and C is at 1, -2. We're going to reflect this over the x-axis. Well, again, since we're down here, this is the x-axis and this is the y-axis. If we're reflecting this over the x-axis, we're just going to move this above the line as far as it is below the line. So we're down 2, so we're going to go up 2, and C prime is right here. And that's really all we needed to know. So the coordinates of C prime are 1, +2. Okay, so if you notice, when we reflect over the x-axis, the y-coordinate changes to a positive. Let's look at the next one. Okay, the next type of transformation is called a translation. Translation is a transformation that moves every point of the preimage the same distance in the same direction. In this case, let's say it slides every point of the preimage the same distance in the same direction. So we did here. Here's our preimage. Again, pre-image is where we start. And we move it down here, so we just slid it. Nothing turned or flipped or anything. It just slid. And we have the image here with A prime, B prime, C prime. Let's look at example 1. Determine whether each image is a translation, right? Yes or no. Look at A. Did we slide this? No, we did not. We actually kind of rotated that around, didn't we? So we're going to say, no, it's not. How about B? Did we slide that lightning bolt? Yes, we did. That is a translation. And C, did we slide this figure? Yes, we did. It looks slightly different, but in this case, we just slid it. Let's look at example 2. It says PQ has endpoints P and Q. Graph PQ and the image under the translation. Okay, so PQ, let's go and plot that. So P is -1, +3, right here. It's P. Q is at +2, +2. Okay, and that's a line segment, so we can draw a line between them. And let's make that point a little bigger. And that point a little bigger. Okay. We want to slide it left 2 and down 4. So we're going to take the P, go down 2, back 2, 1, 2, and then down 4. 1, 2, 3, 4. Alright, and that point is now known as P prime. Q, we're going to do the same thing. Left 2, down 4. 1, 2, 3, 4. And that one is going to be Q prime. Draw a line between them. That's our answer. B prime, Q prime. Now we have rectangle PQRS with those vertices. We're going to graph rectangle, and then we're going to translate it. So let's graph PQRS. P is at -3, positive 5. That's P. Q is at -4, -2, or positive 2, right there. That's Q. R is at positive 2, 0. And S is at positive 3, 1, 2, 3, positive 3. That's S. So I'm going to draw lines between those points. Greatest rectangle. This rectangle. Now we're going to change the x's. We're going to add 4 to the x's and subtract 7 from the y's. So that means we're going to go right 4 and down 7. So let's start with the P. So 1, 2, 3, 4 down. 1, 2, 3, 4, 5, 6, 7. And there's point P prime. Let's do Q. We're going plus 4. 1, 2, 3, 4, down 7. 1, 2, 5, 6, 7. And that will be Q prime. R plus 4. 1, 2, 3, 4, down 7. 1, 2, 3, 4, 5, 6, 7. And then S, 1, 2, 3, 4, down 1, 2, 3, 4, 6, 7. That'll be R prime and S prime. And if we connect the dots, P prime, Q prime, R prime, S prime is right there. And let's see. Now, to give us a translation, we need to find out what we did. So remember, the notation is going to be X, Y, and our rotation is going to be something X and something Y. Alright, so we can just take, looks like they're the same exact shape, so we just find out how one of them moves, we'll know how they all moved. So let's just do C. How far did we move this now? First of all, let's look which one is the new one and which one is the old one. The old one is the one without the primes. So we're going to have to start with this one. How did we get to C? Well, we went C prime. We went 1, 2, 3, 4, 5, 6, 7, 8, 9. So X minus 9. So we're going to say X minus 9. And Y is going 1, 2, 3, 4, 5, 6, 7. Y plus 7. And you could check those if you wanted to. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. So work out. So our answer is X minus 9 and Y plus 7. And that is translations.